Good day to all of you. Today we shall discuss about model question paper Set-2, third semester BE degree examination question paper and its solution of the subject Digital Design and Computer Organization with the subject code BCS302. In that first module 1 question number 1A, demonstrate the working of NAND and XOR gate for 6 marks. Solution. So first we shall take up NAND gate. This is logic symbol of NAND gate. Here for 2 input NAND gate is shown. X and Y are the inputs, F is the output. So logic equation is F equal to X ANDed with Y whole dash. So this is for AND gate. Whole dash means complementation of AND gate means it will be NAND gate. So this is the logic equation for 2 input NAND gate shown here. Its truth table is here. In the truth table, inputs are listed here. This is output column. So x, y are the inputs, f is the output, which is equal to xy whole dash. For 2 input system, there can be 2 raised to 2 4 possible input combinations. They are here 0 0 0 1 1 0 1 1. So when any 1 is 0 here, the output will be 1. Because in case of AND gate, when any one input is 0, the output would be 0. Because NAND gate is complement of that, when any one input is 0, the output will be 1. And when all the inputs are logic 1, the output will be 0. So with this truth table, the concluding statement for the behavior we can write. Only when all the inputs are logic 1, the output is logic 0. Conversely, another statement also could be written. When any one of the input is logic 0, only then the output is logic 1. That also can be written. Okay. So this is for 2 input NAND gate. For multi input means, suppose for example 3 input, if you take here x, y, z, let those be the 3 inputs here. Here x ANDed with y ANDed with z whole dash we will write. Here x, y, one more input column we will write z. Then 3 inputs means 2 raised to 3, 8 input combination starting from 0 to 7. That is 0 0 0 to 1 1 1. And accordingly we'll have to write when any one is 0 here, the output would be 1. Only when for all inputs, when they are logic 1, the output will be 0. So that would be for 3 input NAND gate, and this can be extended for 4 input NAND gate. Anyway, the concluding statement is this. This is generalized statement. It follows true for any input NAND gate. Okay. That is all about NAND gate. Next we shall move on to XOR gate. So this is logic symbol for XOR gate. 2 input XOR gate we have shown here. Let x, y be the 2 inputs, f be the output. Then logic equation is equal to f equal to x XORed with y. So this is XOR gate symbol. This can be expanded as xy dash plus x dash y. So this is the another form of logic equation for 2 input XOR gate. So this can be written from truth table that I will show next. So this is truth table of XOR gate. So 2 inputs are listed here and output is listed in this column. 2 inputs means 2 raised to 2, 4 possible input combinations will be there. They are 0 0 0 1 1 0 1 1. Here when both are 0 0, output is 0. When both are 1, the output is 0. So here for 0 1 combination and 1 0 combination, the output is 1. So if you observe this truth table, we can see that the F output is true. Here 1 and 1 means it is true for these set of input combinations. That is x is 0, y is 1, x dash y. So here for x dash y combination it is true, or it is also true for 1 0 combination means x y dash combination. That is why f equal to xy dash plus x dash y also holds good for XOR gate. Okay. So next, instead of 2 input XOR gate, if we take 3 input XOR gate, the logic symbol will be like this. Let X, Y, Z be the inputs, F be the output. Instead of only 2, here 3 are taken. Always the output of gate will be only 1. So F equal to X XORed with Y XORed with Z. So this is the logic equation for XOR gate. Because only with 2 input XOR gate truth table we cannot conclude its behavior. So let us see to the truth table of multi-input in that 3 input XOR gate. This is the truth table for 3 input XOR gate. X, Y, Z are the 3 inputs. When 3 inputs, 2 raised to 3 possible input combinations will be there. That is from 0, 0, 0 to 1, 1, 1. So what can be the combinations? 0, 0, 0, 0, 0, 1. So this is decimal 0, decimal 1 written in binary. So 2 raised to 3 means 8. 0 to 7. So this is 0 to 7. Combinations in binary will have to write with 3 bits because it is 3 input XOR gate. Next, this is the column for F, which is equal to X XORed with Y XORed with Z. So for 0, 0, 0 combination, output is 0. 0, 0, 1 output is 1. For 0, 1, 0, 1. For 0, 1, 1, 0. For 1, 0, 0, 1. For 1, 0, 1, 0. For 1, 1, 0, 0. For 1, 1, 1, 1. So how the output behaves here? How we can write the output here? So if you observe here, no logic ones means 0 number of logic ones. 0 number is treated as even number, hence the output is 0. Here on input side, 1 logic 1 is there. Means 1 number means it is odd number. Odd number of logic 1s are there. The output is 1. Here also odd number of logic 1. But here 1, 2. 2 number of logic 1 means even number of logic 1s on input side, hence output is 0. So here odd number of logic 1s 1. Even number of logic 1s 0. Even number of logic 1s 0. Here 1, 2, 3 odd number of logic 1s, hence 1. So from this truth table now we can conclude for the behavior of XOR gate that XOR gate is an odd function gate. That is output is logic 1 only when there are odd number of logic 1s on the input side. Okay. So that is all about NAND gate and XOR gate. That completes first question answer. That is question number 1A. Next question number 1B. Explain the working of test bench in Verilog. 6 marks. Solution. A Verilog test bench is a code module that describes the stimulus, that is set of inputs, to a logic design and checks whether the design's output matches its specification, yes or no. Means we design a logic circuit in Verilog program. Whether that circuit works satisfactorily according to specification, yes or no, means it should be given set of inputs. For that, another code module or program is written in Verilog that is called as test bench. This program test bench gives inputs to that program, means to the circuit in that program, and checks whether the design's outputs, means the output of that circuit, matches its specification, means whether it is behaving according to the requirements for which it is designed, yes or no. So that code module is called as test bench. When using Verilog to design digital circuits, we normally also create a test bench to stimulate the code and ensure that it functions as expected. Means first we write a code module or a program in Verilog to design a logic circuit. Next we write another code module or another Verilog program called test bench, which will give the inputs to the first one to check whether the circuit designed in it functions as expected, yes or no. Right? Next we shall see a Verilog code for a simple logic circuit, another code module called test bench, which will give the inputs to this first one. So this is the example module Verilog program in which we design a circuit. So in this we are creating only one AND gate, 2 input AND gate. That is the simple logic circuit. So logic gate we are creating here. So Verilog code for AND gate. So that program starts here. This Verilog module for creating AND gate. So module, end module. These are reserved words. This is start of the program. This is end of program. So module program 1. So its name is program 1. In bracket x comma y comma f bracket complete semicolon. So in this bracket we list all the inputs and outputs. So because we are going to create a 2 input AND gate, so x and y we are taking for inputs, f for output. Next, after inside the program, so we have to list these separately, which are inputs, which are outputs. Input x comma y semicolon. These are declared as inputs. This f is declared as output. So next, the processing statement. So this is designing statement which will design a logic gate, that is AND gate. AND, this is reserved word. We should write this way only in small case. AND, this is for AND gate. G1, the name of the AND gate. In bracket capital letter comma F. So first we have to write output literal only here. Here in any order we can list both inputs and outputs, but when we are going to create a gate, logic gate with the reserved word, here inside the bracket first output only we should mention, comma, then whatever inputs are there, x comma y, 2 inputs, bracket complete, semicolon. This statement inside in the software, it will create a AND gate with 2 inputs x and y, and its output will be reflected on F literal. So this is Verilog program for design of logic gate, that is AND gate. Whether this AND gate performs according to the requirement, yes or no. So what is the requirement of AND gate? When x and y both are 1, only then output should be 1, otherwise output should be 0. Then what they should be given? It should be given 2 inputs. So this is start of test bench Verilog program, another module which is going to give the inputs to this AND gate module. So here module program 1 underscore TB, any name we can give. Easy to identify that this is the test bench for program 1. The name given is program 1 underscore TB semicolon. Here reg, these are the reserved words, register, which will specify the inputs x, y, semicolon, semicolon. So output will be reflected on F here, which is declared as wire, semicolon. So afterwards, anyway, when we create a module for test bench, it will substitute all these lines. So our concentration should be on adding the stimulus, means the set of inputs properly. That is different combinations for these two inputs. That is this part, add stimulus here. So here we'll have to add the required set of input combinations that will be able to check the given circuit which is designed in another module, that is AND gate here. Because there are 2 inputs, here 0 0 will be given by that software only. We will give 0 1 combination, 1 0 combination, 1 1 combination. Each time after giving the inputs, hash 100 semicolon. This gives 100 nanoseconds after giving this input to wait till getting the output. So after every set of inputs, hash 100 nanoseconds. This is end module. Because module was the start of test bench, end module is also end of the test bench. So this way test bench is written. Here Verilog code for one AND gate is written, that is Verilog module. It is for 2 input AND gate, x, y are the inputs and f is the output. The name of the gate is G1. The module is written in structural model. So AND, using a reserved word we are writing, that kind of writing Verilog program is structural model. The test bench shows, that is the second program, 4 possible stimulus for 2 input AND gate. So 00 is given by software. We have to type these three, 011011. Usually Xilinx software we use in developing Verilog programs. When executed, we get output for all these four inputs to a 2-input AND gate, and we can verify the behavior seeing to timing diagram that is given by the software. For example, we use Xilinx software to create and run Verilog programs. It will give timing diagram. When we execute this Verilog module for AND gate along with its another module called test bench, we will get timing diagram. By verifying those timing diagram for these four cases, whether output is one only for one and one input, yes or no, that we can do. So that is what is explain the working of test bench in Verilog. The answer for that question. Okay. Next question number 1C. Simplify the following Boolean function into sum of products, that is SOP, and product of sums, that is POS form. The given expression is f of a, b, c, d is equal to sigma, that is sum of minterms 0, 6, 8, 13, 14, and don't care conditions are sigma of 2, 4, 10. Right? This is asked for 8 marks. In this there are two problems. One, we have to find the simplified form in SOP, sum of products, another in POS form, that is product of sums. First, considering sum of products. So for both, first we must be able to fill the K map. There are 4 variables in the input, hence in the K map 2 raised to 4, that is 16 squares will have to draw. And one more important point is don't care conditions will have to utilize as per the need for simplification. So in SOP form, don't care conditions will be treated as logic 1. In POS form, they will be treated as logic 0. That is what is the meaning of utilizing don't care condition as per the need of simplification. So first, finding simplified sum of products form of Boolean equation. For that, K map is drawn here. 4 variable Boolean expression means 2 raised to 4. 16 squares are drawn here. In this, whichever minterms are there in the function, they will be filled as 1 because sum of minterms is given here. So 0, 6, 8, 13, 14. In those places in K map, we have to fill 1. So this is minterm 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 places. So minterm 0 is there. So minterm 0 place 1. So then minterm 1 is not there, 2 is not there, 3 is not there, 4 is not there, 5 is not there. But 6 is there. Hence there we have filled 1. 7 is not there. Minterm 8 is there. Hence 1 there. 9 is not there. 10, 11, 12 are not there. But 13 is there. So that 13 is filled here. So 14. This 14 is here. Hence filled 1. 15 is not there. Next, don't care conditions we can fill as D or cross. So 2, 4, 10. 0, 1, 2. So 2 place here don't care condition. 3, 4. So that is 4 don't care condition. 5, 6, 7, 8, 9, 10. So 10 place don't care condition. So this is how minterms and don't care conditions are filled. Next, we have to group ones in case of SOP. So to cover this one, so nowhere a group of 16 or 8, that is octet, not possible. So but this one with the treating this don't care as 1 and this one also 1 and already 1 is here. These 4 corner ones make a quad, a group of 4 adjacent ones. Why? Because on this line if you take a fold, these 2 1 fall on this. Next again on this line if you take a fold, all come in one square. Hence these 4 form one quad. So that is first group we have written. Then to cover these 2, with the help of these 2 don't care condition, treating them as 1, so one quad is formed. This forms one group. How? On this, if you take a fold, these 2 fall on these 2. Again on this line if you take a fold, all come in one square. Hence all these 4 make one quad, that is second group. So with two groups, these two ones and these two ones are covered, but remaining one, this one, nowhere octet, nowhere quad also. Pair also not possible because this is here, no adjacent ones there. But diagonally we cannot group, treating this as one. So hence this one forms its own individual group, that is group number 3. So grouping is over because all ones with minimum number of groups, they are covered. Next, group wise, what is row wise common and column wise common, that we have to write. So in first group 1, 2, 3, 4 members are there. These two members, these two. So all the 4 members, they are covered in these two rows. 0, 0, 1, 0. So this 0 is common corresponding to B. Hence it is B dash. And column wise what is common, that we have to write. So these 4 members, they are covered in these two columns. 0, 0, 1, 0. This 0 is common with respect to D, hence D dash. So B dash and D dash. So this is the common term in first group, row wise and column wise. Row wise B dash and column wise D dash. So in the second group, so all these 4 members, if you observe, they are covered in 4 rows. Row wise 0, 0, 0, 1, 1, 1, 1, 0. Nothing is common. Leave it. So these 4 members come in single column. 1, 0 is there, which is common with respect to CD. So C D dash. That is what is written here. So this is with respect to second group. This is third group. Only 1 is there. That is covered in this row. Row wise 1, 1. That is with respect to AB. So AB. Then and column wise this falls in this column. 0, 1 for CD means C dash D. C dash D. So AB and C dash D. That is the common term in third group. Row wise AB, column wise C dash D. Right? In between and sign we write. So now these 3 form the final expression. Hence simplified sum of products Boolean function is f of ABCD equal to B dash D dash plus C D dash plus AB C dash D. Okay. So these are products. This is sum, hence sum of products form. In that form, simplified expression we have found. Okay. So next we shall go to second part of the question, that is to find the simplified expression in product of sums form. So second part, in that simplified expression in the form of POS, product of sums form of Boolean function, we are going to get. So K-map will remain the same because with same expression we will have to fill, right? But for product of sums we have to consider zeros and don't care conditions. So don't care conditions must be treated as per the need of simplification. So whichever are free here, they will be filled with 0 and don't care conditions as it is, right? So next grouping of zeros. So these 4, they are grouped as 1. That is a quad. So these 4 zeros are over. Next to cover this, nowhere quad, octet, pair is possible here. So treating this don't care as 0, this 0 is paired with that. That is second group. So 4 zeros, this 5th 0 is over. These 3 are remaining. Now these 2 zeros, with the help of these 2 zeros, one quad is formed. Hence these 2 zeros are covered. This one is remaining. Now this is with this and these 2, a quad is formed. Okay, to cover this 4th group, that is a quad is formed. Right? After grouping, we have to find row wise what is common, column wise what is common. If 0, same as it is, we have to take the literal, just reverse of this. If 1, complement we have to take. Instead of and, row wise plus column wise. So what is common, that term we have to write. So in first group, these 4 zeros, they are covered in these 2 rows, 0, 0, 0, 1. This 0 with respect to A, it is common, hence A. So 0 means as it is, A. Instead of and, plus. So column wise for these 4, they are covered in these 2 columns 0, 1, 1, 1, 1 with respect to D, hence D dash. So A plus D dash is there for first group. A is row wise common plus D dash is column wise common. So next for second group, this pair, so members fall in these 2 rows 0, 1, 1, 1. This one is common with respect to B, hence B dash, plus column wise these 2 members come in this column 0, 0 correspond to CD, hence C plus D. So B dash row wise plus C plus D column wise. So this is common term in second group. Then third group, here this green colored, so 4 members come in all 4 rows here, row wise here 0, 0, 0, 1, 1, 1, 1, 0, nothing is common, leave it. But for these members they come in this column 1, 1 with respect to CD means C dash plus D dash, that is common in third group. Then in fourth group, this blue colored, so that is fourth group, 4 members, these 2 and these 2, they come in these 2 rows here 0, 0, 1, 0. This 0, 0 is common with respect to B, hence B as it is, plus these 2 members and these 2 members are covered in these 2 columns 0, 1, 1, 1. This is second one with respect to D, hence D dash. So B plus D dash. This is how row wise plus column wise what are common, they are written for all the groups, and these form the final expression. Hence simplified product of sums POS form of Boolean function is f of abcd is equal to a plus d dash and b dash plus c plus d and c dash plus d dash and b plus d dash. These are all sums. This indicates, this AND function indicates product. So the simplified expression is in product of sums form. So that is the solution of question number 1C. That was asked for 8 marks. I hope you understood this. Thank you.